Hello everyone. My name is Anderson Rocha. I'm a professor here at the Institute of Computing, University of Campinas. And we have the pleasure today to have this talk by my colleague, Professor Claudionor Coelho. And the title is very interesting and catchy. It's all about the journey. This talk is part of a partnership that we have with the Department of Informatics of PUC-Rio, here today represented by the director of this department, Professor Marcus Endler, who I will give the word just in a little while. So I had the opportunity to discuss many interesting topics with Claudionor, and of course, I was enticed with his research and I invited him to talk with us, and he kindly accepted it. Claudionor is right now the VP Fellow of AI and Head of AI Labs at Palo Alto Networks, leading new research and products on time series analysis, causality, and neural-symbolic computing. Previously, he worked with machine learning and deep learning at Google, and he is the creator of QKeras, a deep learning package for quantization on top of Keras, with support for automatic quantization being used by CERN, and I'm sure that you know CERN is very important. And this research in particular made the cover of Nature Machine Intelligence in August 2021. He was the VP of Software Engineering, Machine Learning, and Deep Learning at NVXL Technology. And he is currently an invited professor for deep learning at Santa Clara University. And previously, he was an associate professor of computer science at UFMG, Brazil. He has a Ph.D. in EECS, and it's from Stanford, and an MBA from IBMEC Business School. As I said, this talk is organized in partnership with PUC-Rio, and is also part of our artificial intelligence and the reasoning for complex data lab here at Unicamp, Recod.ai. And I'm very glad with your acceptance, Claudionor, and I give the word to Marcus to also thank you. Marcus?
So good evening to all. It's a pleasure to have here Claudionor Coelho giving a talk to us. I think from what Anderson, how he introduced him, it's obvious that Claudionor has done many contributions, and I'm very looking forward to learning about not machine learning but human learning about your achievements. And I just want to say that this is part of the Conexão Rio-Campinas, how we call it, and we will have every month at least also a panel where scientists from Unicamp and scientists from PUC-Rio will discuss some topic. So watch the announcement in LinkedIn and in the pages of the departments, and I think that we will have also in the future some very nice panels and discussion. But today the floor is for Claudionor, please.
Thank you, Marcos. And Claudionor, the floor is all yours. Normally we have like about 50 minutes for presentation and then some 30 minutes for questions. You feel free to organize how you prefer. And once again, thank you very much. Please go ahead and share your screen.
So first of all, thank you very much for the opportunity. Actually, I consider Unicamp to be a kind of sister university. I almost ended up teaching there when I came from my PhD. And just to give a little bit about why I decided to do this title, intriguing title. And the idea here was that initially I was going to do only a technical talk, and then my paper appeared on Nature AI on the cover page. I'll just mention that briefly. And then I had an idea to show you a little bit more than just the technical content and how you can bring innovation to your organization. So first of all, who am I? Then it's all about the journey, talk a little bit about that, how to create an applied research organization in your company. And then I'm going to talk about the work, one of the pieces of work that we have been doing, which is log2ns. So a little bit more complete description on my bio here. I think I'm just going to skip almost everything, except that I was one of the people who created the initial strategy, and I was an angel investor to Konami. And and also right now I'm on the tab of Condati. Okay. And another thing that you may not know is that I took the ACM programming context to the Southern Hemisphere. And at that time, I had like Professor Dahabi from Unicamp, and later on Professor Clarice from PUC-Rio also participate in the first context that we had at that time. Okay, so this is like the cover page of the Nature Machine Intelligence. And this work was developed while I was at Google, and with like a large team also of supporters from CERN. And actually CERN uses the work that we did. And just as like an advertisement here, I was talking to people from my my collaborators at CERN, and they actually told me, since you're going to do a presentation, can I actually advertise this PhD position that we have in CERN? So if you're interested in pursuing a PhD using machine learning for new particle detection, so there is like this, they are accepting applications until October 1st. Okay, this is together with ETH Zurich. So going back to this slide here, the reason why I decided to actually do this presentation in this first part is because I was discussing with a few ex-students of mine, and then one of them decided to post this on Twitter. And then I decided maybe I told Anderson saying, I'm going to just talk about the journey, because when I was discussing with my ex-students, I actually told them, in 1989, I did a literature review of systolic arrays, and 32 years later, I published that in Nature Machine Intelligence. Not exactly the same, of course, but uses the same stuff that I did the review 32 years. And then some people said, wow, it takes 32 years for you to publish something in Nature, and you know, all sorts of jokes that people can say. And then I said, but guys, you have to consider the journey. You cannot just consider the endpoint, but you have to consider the journey. And that's exactly why I decided to give you a little bit of my experience on the journey itself. And then I decided to put a few slides, because I have done that multiple times, on how to create an applied research organization in your company, and also in my experience passing through several other companies before. So the first thing that happens is this: companies have pressure on investors to deliver products, not papers. Okay, so if you want to do an applied research organization, you want to be able to publish papers. So you need to correlate the research that you're doing with the products that you're developing. So not necessarily you're going to be able to create like a research that is going to be used 10 years from now, but there is still a lot of opportunity to create a research that is going to be used in the shorter to medium term inside an organization. The other comment that I would like to do is that even companies that have tradition or had tradition in the past to have a strong research organization, like a pure research organization, eventually it becomes harder and harder to justify if they're not attached to products. Okay, I remember when I was doing my PhD back in the 90s, that there was an ADA company that had a research lab in the Bay Area, and it was like pure research. The only objective they had was to publish papers, and eventually they had to shut down the research lab, because there was a stronger and stronger pressure from investors to be able to have that tied to products. However, the way that I usually do is this: I want to be able to hire people who publish at new RIPs, who publish at ICML and other conferences. And the only reason those people would consider me to be an employer is if I have papers published in those conferences. So I always put on my OKRs, like objective key results, that I need to have publications in my organization in order to be able to attract top candidates, publishing candidates. So another thing is that if you're going to be looking at how to do research and applied research, to look for opportunities to innovate when no one is looking at, and it's very easy to do that. Okay, I have done that countless times. If you just look at an organization where people are investing a lot of times, you're going to find holes that nobody's investing any time on it, where the values is great. And it's very funny because after you start developing, showing results on this, and people will come to you and say, oh, but we should have done that. That's high value. Why no one has looked into that in your organization? So always look to innovate and look for opportunities to innovate where no one is looking for one. You have to understand that if you're going to innovate, you're going to innovate once, but you're going to fail several times. So I usually tell my team that if you're going to fail, and I know that everyone is going to fail multiple times, you need to fail fast, okay? Another comment, and I have a separate slide on that, is disruptive innovation occurs once. However, continuous innovation happens many more times, okay? So another thing that I've seen people do is that papers take a long time to be published these days. And even the papers that you try to publish, if it's like the top conferences like NeurIPS and ICML and etc., there is a chance that you need to resubmit the papers twice or 3 times until the paper is accepted. So a lot of organizations, they are basically using archive and blogs to establish ownership of ideas if you're not going to patent that. Of course, if you're going to patent that, patent first and then submit to archive or to blogs later on. But I have some cases where patent applications with me took more than 10 years from a response from a patent organization. So my recommendation to you is patent in places where you're going to get a response in 2 years or less, but not more than that, especially in high tech. Actually, this next bullet is very interesting because I discussed about that with Anderson. Diversity is key to innovation. I do not want to hire people who think just like me, but I want to hire people actually who is going to think against me in some sense, or who is going to think in a different way. Because I'm only going to be able to innovate if I have people with a diverse type of thought. Okay, so taken to the extreme, the teams that I built, even when I was at Jasper, they tend to have like any type of diversity, diverse in gender, diverse in line of thought, where the person comes from, and I try to always to put diversity to the extreme, because that's how I've been able always to innovate. Okay, and another thing is that some people tend to take it for yourself. I try to operate in networks, and I try to acknowledge people over and over again by their contributions. Then that's helps you to build a solid organization in a company. And just like as a personal advice, just remember 30 years is a very long time. You're going to need to reinvent yourself several times, okay? So in terms of disruptive innovation versus continuous innovation, most important innovations for your organization, you have to understand that they will come from observing faults in the whole chain. This is like, if you read the book, Innovation Entrepreneurship, Peter Drucker, it's one of the main tasks on this. And when I was at Jasper, we won this award here on the upper right corner, which is the one of the most innovative companies in America. And actually, the reason why we got this award was not because of technical innovation, but just because until Jasper, people needed a PhD in formal or math to formally verify digital circuits. What we did, we created like we created a system in which we put formal technology in the hands of a person who did not have math or formal background. and we automated everything in formal as we could, and that made our tool to be used by many more people. So you can see here in this example that we created an innovation, actually that made us win an award that has nothing to do with the technology. We didn't develop the fastest such solver to do that. We didn't develop any new fancy new technology, machine learning, but just to look at how the things are going to be used and how to make sure that any holes in the chain, they're solved by the system. And you have to understand that most likely you're going to be performing incremental continuous innovation in the majority of time. And you should use that to make your organization more credible on behalf of the entire company. You're going to perform disruptive innovation only a few times in your career. And just to give an idea, what I call a disruptive innovation is not necessarily what you think that it's disruptive, but what the market is going to accept as disruptive. And I have done that once every 5 years, just to give an idea. Most of my other innovations, they're incremental innovations, but disruptive innovations I have done like maybe once every 5 years in my career. It requires lots of, these days, to do disruptive innovation, it requires a lot of marketing and connections effort. It did not used to be like that, but because of the world, connected world as we are, in people operating network, sometimes it's not about who comes first these days, but who has the largest marketing and connection network. So because of that, remember, nothing these days are done in isolation. Do not be afraid to operate in network and to build strong collaborative network support system for your innovations, okay? So moving forward, I'm going to show you one of the things that we have done. I've been with Palo Alto Networks 1 year. One of the works that we have done in our team is basically log2ns. Oh, I forgot to say something here. I just want to make a comment here that what I'm going to present here does not reflect the views of my current or products of my current or previous employers. I forgot to put this like basic disclaimer. When I saw the logo of Palo Alto Networks, I remember that. In any case, this is like one of the research works that we have been doing, which is like we're going to be merging deep learning and formal to prevent survivorship bias. And the agenda here, I'm going to talk a little bit about our AI labs at Palo Alto Networks. Then I'm going to talk about formal, and then survivorship bias, and then how to do that, and then talk to you about the machine learning and the part, and show you some real examples and conclusions. And I'm affiliated with AI labs in Palo Alto Networks. And I have been working on some areas of, I call it like frontier of artificial intelligence. But the reason why you have like applied in the name is because it's not free for everything. It has to be applied to Palo Alto Networks business, which is in the firewall business. And in this particular case, I'm interested in advanced time series analysis, how to push the boundaries of what people do, causal inference, neural-symbolic computation, and many more. And I'm starting to build like postdoc positions in Palo Alto Networks, and we're going to have those positions open soon. Initially, I want to say, remember, I told you like it's all about the journey. And my journey started with formal, and I have worked with formal technologies for over 25 years. This picture here on the right is the original picture of the team who created Jasper Design Automation. This picture is taken in Belo Horizonte. And it's very interesting because this picture was like the first 4 people. And in formal, I sold 2 companies on formal. One was Verplex Systems, the other one was Jasper Design Automation. And one interesting thing here is that when I was at Jasper, we actually did some work on using machine learning together with formal verification. That research work was the PhD thesis of an ex-student of mine called Georgia. She's here on the right. And this is like one of the first papers ever to use machine learning and formal together in the EDA industry. Okay. So after I actually sold the Jasper, I said, I sold 2 companies in formal. I don't want to do any more formal. I want to move out of formal, and I did that in 2015. And that reminds me of this book. If you know Star Trek, you know that after doing Spock and Star Trek for several years, Leonard Nimoy wrote this book saying, "I'm not Spock. I cannot get like a position that is not outside Spock position. Then I'm not Spock." Okay. And it's very interesting because even when I left Jasper, formal kept coming back to me, and I always say, I don't want to do formal anymore. I'm done with formal. And then, like in this new position at Palo Alto Networks, I decided to embrace my formal journey. Okay, and I started looking into ways on how to integrate symbolic models into machine learning, deep learning framework to solve real problems. And actually, according to a colleague of mine from Rice University, to have one of the first products in history to actually to use formal and machine learning in a collaborative way. Okay, and that reminds me of Spock, because after several years saying that he was not Spock, at some point he decided to say, okay, I am Spock. And if you search on Amazon, you're going to find those two books. And I every time that I look at those two books, it reminds of my history. So the idea is here, machine learning, deep learning, they can usually give an answer in the interval between 0 and 1. I keep joking saying that if it tells you a response with 0, with a confidence level of 1, of 100%, actually probably it means that your model is broken. However, formal can always give you an answer in the interval, not in the interval, in the set 0 and 1. And when you use it in conjunction, you can get a closed interval of 0, 1. And that's exactly what you're trying to do. And let me show you why is that. So what is survivorship bias? When we're writing our paper, actually, someone sent me this on Facebook and LinkedIn, this picture. And this picture keeps coming back on Facebook and LinkedIn several times a year, right? The idea is that during the Second World War, people are investigating how planes, they could be enhanced in the structure in order to avoid the planes from being shot down. And someone looked then into where the planes received the bullets, and this is of course a pictorial representation. They came up with the idea, let's reinforce the structure in those places where the planes received the bullets, because those places are the places that if we enhance the structure, the plane is not going to crash. And then a statistician came and said, actually, this is completely wrong. You should reinforce the structure in the places where you don't see any bullets, because it means that if the plane receives any bullets, for example, in the engine, the chance that the plane is going to be returning is very, very small. And the idea is that survivorship bias is exactly this. It's the systematic error about understanding of the world when we analyze data based only on success cases. And in order to be able to reach this conclusion, we started looking at this picture and said, what made this picture so special? First of all, you could analyze the positive and the lack of positive data in a 2D representation. Remember that our observational data consisted only the red dots here, which is like positive examples. And without negative scenarios or failures, if I don't have a way to represent them or to measure them, our capability to derive useful insights will be compromised. Okay, so our idea is exactly this, is to be able to use positive and lack of positive examples in order to gain insights. And this is when applied to reactive systems. What is a reactive system? Is a system that reacts to inputs by generating outputs. And usually the complexity of a reactive system can be very high. It can be an integrated circuit. Remember, I worked on EDA industry in formal verification for several years. It can be to airplanes. Okay, I was actually a passenger of the plane that was supposed to crash in the ocean, the Air France flight from Rio. I had a ticket booked on that flight until Friday. On Friday, I decided to cancel that flight because I had some other meetings that I had to join, and that plane crashed on the Sunday. And Firewalls, which is the business of Palo Alto Networks. And so the idea is that we have real world here, and we have the inputs, we have the system. We basically supply inputs to the real world. the real world response, and then we collect this as logs. And we are assuming that we have an underlying model of the system here. And this model is like a mathematical model that you can inquire. We could even generate input-output pairs from it, but it's a mathematical model of the real world to some level of abstraction. And we are going to be collecting those logs. And you have to understand that those logs, they have exactly the same problems as survivorship bias problems, because most of those logs, they will represent only normal behavior of the system, right? By construction on how the model works. No model is built to fail. The model is built to work like for extended periods of time until something bad happens to the model. And because we are basically doing analysis on the logs of those systems, it can lead to wrong insight or actionable insights because we're only seeing good data. We're not seeing bad data, okay? So that's where statistical model checking comes together hand to hand with symbolic. This picture was, there was an original version of this picture that is from this article here. We just, this year we revisited this picture using new types of technology and our understanding. But the idea is that you have observational data coming from the logs. We have configurations that comes from mathematical models. And we have like a query layer here that decides whether we are going to use the statistical model checking or the symbolic model to do the query. And by basically doing queries on both models, we can actually obtain hypotheses or knowledge of the system. So let me talk first about the machine learning portion. And suppose that you want to check if your IoT devices can access. Oh, okay, right here. Yeah, I'm going to talk about IoT devices here. So where our IoT devices are going to be accessing my personal information. So we have here a firewall, and I have an air conditioning here. And this is my home. I want to check if this air conditioning system right now, as you can imagine, any device that you have or any Wi-Fi network, home network, probably have like dozens or maybe hundreds of small devices, tiny devices connected in your home, coming from Nest, dishwasher, washer, dryer, microwave ovens, everything these days is connected to the internet. And you want to know if your air conditioning can access your personal camera. This also applies to a corporate. You want to check if your air conditioning can access the corporate data. And usually those corporate data or those areas, they're called trusted zones. So if you have ever worked on this area, I mean, to formulate a theory about something, you basically formulate a question: is IoT accessing my trusted zones? And then you get observational data and you start analyzing the logs. And then you say 100% of the accesses for IoT X1 do not access my trusted zone. The same thing happening for X2 and X3. And then, as usually we do, whenever 3 is magic number, if with 3 examples I cannot find a counterexample, then I create this generalized comment and I say for any IoT X, for whatever X is, for all types of X's, if X is an IoT device, they cannot access my trusted zone. And that's the generalization that you do. Of course, that's usually not how things are happening. And in this breach that happened like a few years ago, 110 million impacted customers at a mail retail store because their conditioning could access the trusted zone. And as a result of that, 110 million customer information, 110 million customers had their information released. What is the problem here? The problem is that in general, you do not know even the question you're looking for, okay? So you're looking for something like this, but remember, like my camera had an IP address, it was in the subnet 10. So somewhere in my case here, my air conditioning got a different subnet than my camera. And that's the thing started going sour because I did not know exactly how to pose that question, and I did not even know what was the question that I wanted to pose. And so this is kind of searching like a needle in the haystack, except that you don't know when you're searching for a needle. And remember, like I worked for formal verification for 25 years, like maybe 30 years. And in formal verification, we have the same problem because people come and tell you, oh, we can check the property that this property is proven to be false, but you usually only write the property after you've seen the bug. If you have never seen the bug, you may not even have noticed that you need to write the property to verify it for the bug. So what we really want is to have like a magic wand. I like Harry Potter, so let's say that I have a magic wand, and with this magic wand, I can start finding correlations between events. Okay, and by doing that, I can just check if I plug in X1, X2, and X3, not necessarily that I want to try to find something as hard as do not access, but I want to try to see if you have two devices that are more or less the same, one is in a trusted zone, the other one is not a trusted zone, do they have the same type of patterns? And then I can start establishing correlations between those events, okay? Which is exactly what you do when you compute embeddings, okay? So what we did here, we basically created global embeddings for all the log entities that we are looking at. And then we use those global embeddings to be grouped, such as in those clusters here. And then I wanted to be able to create like 2D visualizations. And to do the visualization of the clusters, I would basically find something like this, like red bubbles here. Okay, the circles and ellipses. And actually, after we done that, this is like maybe not as nice as those ellipses in the 2D visualization. And of course, there is still one portion missing here, because how many clusters is enough? I know that if I just represent this here by 2 clusters, I'm going to miss a lot of empty space here on the engines and on this part here of the airplane. So there is a question that we need to know what we are missing, okay? But the clusters already give us some useful insights. It tells us why data is being grouped. It can give us like reasons why data is being grouped. And even inside the groups, it gives us why there are outliers in the groups. Okay. And then we started looking this to see how we could check what happens in our firewall. Okay, we had some internal firewalls. We started analyzing the data. We did exactly this flow on the data. And then we saw this here. And you see this name here, right? And then I said, God, wait a minute, is there someone mining Coinbase? Why do I see Coinbase on my network? Coinbase should not be in any corporate network, especially with a level of importance that we just found. What are the implications of that? And finding implications is basically finding correlations between this application. So that's when formal kicks in. And remember, we can now start pinging the formal model for positive, for examples we have not seen before, and then use the machine learning and the logs to query it for correlations and for data in the system. And the idea here is that we want to be able to form hypotheses to debug a system. And right now at this stage, we want this to be free form. So we want to pose a question, like we want to say this query here, right? Or we want to pose questions like, I want IDP not this guy because this has like a more complex logic query. Then we're going to invoke the formal. Or if the query does not, if that query, even though it's a positive query, if it does not exist in the log, and if I cannot find correlation, then it has to go through the formal agent. So we keep iterating between or alternating between a formal and a machine learning engine and the logs itself to find information. And then by that, we try to build a mind map. And I keep joking that, remember, I had to explain this presentation to people who did not know machine learning. people who did not know formal and people who did not know both. So every time that you have to represent or to do a presentation onto something that you have such a wide audience, I usually try to find a picture that has happy faces, hearts, and faces and stuff like that, because it makes it easier to explain. But the idea here is quite simple. We want to build like a free-form graph to be able to debug the problem, and that's how you debug problems in general in your life. So what does that has to do with formal and with like the log2ns? Remember, we form a hypothesis, which is why is Coinbase appearing here, and then I started pairing positive cases that related to Coinbase and negative cases. For example, those negative cases could be things that are logs and negation of IPs. Show me an IP address that is not from the logs, okay? And with that, you can do the same thing with other apps and finding correlations between them. And if you, for example, find there's correlation between accesses to Coinbase and maybe file transfers in your firewall, maybe you're detecting like some illegal activity of someone selling IP, right? The person transfers a file and then there's a payment on Coinbase. On the other hand, if I basically look at Coinbase, tries to do correlation between the apps, and then I look even the correlation with the machine load, probably this reflects the fact that someone is mining cryptocurrency. And you can see that although those two end conditions here, they express something that is illegal in the company. One is a violation of company policy, because you don't want the people using company resources to mine cryptocurrency. The other one is a crime, okay? So you can see by quickly being able to evaluate what's going on and finding the correlations and query the logs and the system about this can help you identify very quickly the patient zero of this problem. So just to summarize what I just discussed here, let's see, yes. So we create a formal model of the reactive system, in our case, the firewall. We collect the logs that represents the observational data. And remember, those logs can be extensive. And then we analyze them using global embeddings. And we create clusters of those global embeddings. And then we visualize the clusters, because you want to be able to visualize positive and negative cases. And then after we do that, we want to start creating hypotheses, okay? And then we do a series of queries, and we keep iterating on 6 here until we form or disprove a hypothesis on what is the problem. And of course, right now, as I mentioned to you, this is like still a manual step. This is kind of a picture that we have in the paper and the queries engine for the firewall can be, it's not that much complicated, but it basically allows you to do conjunctions, the basic conjunctions, disjunctions, and even not negations, okay? And based on this, we basically, of course, if you can find the data on the log, that's much better, because then the response is immediate. But if you cannot find the data in the log, if you cannot do correlations, then we basically switch to a formal engine to get the response for us. So I showed you how to use machine learning, deep learning in conjunction with formal models to avoid survivorship bias. We showed like one of the first products in the market to use neural-symbolic reasoning. We use a build the knowledge and form hypothesis, especially when you want to debug patient zero for a problem. Patient zero is very important because you don't know what is the pattern you're looking for, and you don't know what is the question you want to ask for. So it's very important to be able to debug patient zero problems quickly. For future works, we are looking into whether we can generate the queries in a automatic or semi-automatic way. There is an important problem. Remember, I worked on formal verification for several years, and we're looking into a way to compute the radius of what's missing. And that informal verification is extremely important to know what you're not verifying in the system, okay? And that's related to the radius of your coverage. And we are basically exploring how we can solve this problem. And there seems to be a correlation between logs and episodes of a reinforcement learning system. And you can imagine that if you're basically running a reinforcement learning system and you have like an episode and you have a state that is very, very rare, which is exactly what we're doing. By using machine learning, random simulation, and sticking formal in it, we could probably steer some cases to try reinforcement learning system for states that are rare and you would never be able to achieve. And this is kind of extensions of the work that we're doing. But you can see here that where we got a real problem that we need to solve for a specific, we basically started thinking about taking a step back and thinking in terms about what we need to do to build like a interesting solution for the company. And at the same time, we can advance the state of the art of what people is doing. And this is my presentation. Thank you very much.
Excellent, very nice. Thank you, Claudionor. I was like daydreaming here with some possibilities of the things that you showed and seeing a lot of other applications. Thanks a lot. I will start saying that the way that you treated this one class problem is a very different form that I was used to. So I would definitely take a closer look at what you have done, because I'm used to, I face several of these problems that you mentioned here. And the way that we model this until now is, or you can model that as a one class problem, and then you can use like classifiers of one class, or you can do a totally unsupervised form, but then you end up with the clusters and you need some formal way of verifying them. Or you can do something like ontologies and try to correlate them. So I did some work with ontologies, and it was with the Hub as well, and a former student of ours. And if you want, I can send you the paper later, but the idea was to verify access permissions in Android. And just looking at which permissions you allow the apps to have, we wanted to see if they were like a trusted app or not. And we modeled that in a different way as you did, but the objective was pretty much the same. We didn't know what to look for. We only had examples of one class, and this is awesome. I will share the paper with you later on.
Okay.
So one thing that I would like to kick off here with a question is, you mentioned that you have a free-form graph, and you have very nice formal way that you start with. So right now, the human, I understand that the human is essential to be in the loop to design this formal system, right? And I understand that you want to like steer a little bit and try to derive some of these rules from data. So can you explain a little bit?
Yeah, think about this. Right now, if you're debugging like a bug that you have never seen, a problem that you have never seen, and remember, when you're talking about a firewall, you may be talking about a new type of attack that you have never seen before. You have a time pressure on you because you need to respond to that very quickly, right? If it's like a attack, then you need to be able to figure out what's going on. And people don't have like tons of data. They don't know how to create visualizations of the data. They don't know what the data does not have, okay? Yes. And they need to find, and they don't know what the question they want to ask. That's why we started by doing the visualizations and clustering in visualizations, because by doing those visualizations initially, we can provide some ways for them to actually see how we obtain the clusters of data.
And right now, do you use the clusters to help you drive the question somehow or no? So
the idea here is that, yes, it's used to drive the questions somehow. The user, once he or she looks into the clusters, he or she should be able to look and say, what is happening here? And then right now he can make a query, and by making the query, decide whether you're going to go to formal. If the query, for example, it has negation terms, it means that it's probably not something that the statistical machine learning or even doing on the logs can answer, but you should basically switch to a formal and basically dispatch a formal engine on that.
Very interesting. Have you heard that some people try to model this problem also statistically with extreme value theory.
No,
the
I
same,
have not.
Yeah, I can send you a paper that we did also in that regard. We only had examples of one particular class and very few examples or none from the target class. Using the extreme value theory, we are talking about things that may happen eventually or never, but you don't know.
Mm-hmm.
And then you try to model the normal class. So the things that are not happening and they should not be of interest, but you need those things to model your piece. And that this is based on, for instance, how they calculate the height of the dams in the Netherlands. And it's very rare to have like some rain or some increase in the water level, because they model that with the normal heights that they measure every day. So extreme value theory has been used somehow for this, but it's really nice the way that you treated bringing together like machine learning and your expertise in formal. Very nice.
Think about that.
Go ahead.
Oh, let me just mention something. For 30 years, I worked out on formal verification in the context of chip design. Right now, when you release one of those big chip companies, they release a chip. Usually they end up running emulations or simulations of the chip for several weeks or months. And sometimes they have gigabytes or gigacycles of things running. For example, a new cell phone chip, the processor, they actually boot Android several times. They let Android be running on the chips for some time to see if there are any bugs in the hardware, okay? Once they have a problem, they don't know where the problem is, but they have terabytes of data, okay? Yeah. They don't know where to start.
Yep.
They just have the log. And the problem that they have is that, first of all, those reactive systems are extremely nonlinear, right? That's why SAT solvers are nonlinear, right? So digital circuits are extremely nonlinear circuits. So, and what we try to do is to try to find some regular behavior on those logs in such a way that you can actually do a representation from the states that you represented on the system in some meaningful way. So usually the way that I position is this. The system is nonlinear, is a state-based system, a reactive system. By doing the embeddings, we transport this system to a high-dimensional space where we can find the clusters by linearizing the high-dimensional space. That's basically, to some sense, that's what we are doing.
Before I start with the questions in the chat, I have one other question. How do we split the log to create the embeddings? Because, I mean, you can divide by day, you can divide like by event, by equipment. How do you do that?
For a firewall or for a networking device, it's quite simple. There's a paper called IP2VEC from 2019, I think. What they do, they basically get the log entry IP2VEC saying something like this, right? Source IP, destination IP, and they get this entry on the log, which is a state, right?
Right.
If you think about it. And they basically run this through an embedding, the log through an embedding.
Did you need to fine-tune the embedding for log data, or you used from scratch?
We started with global embeddings. Global embeddings is that we try to build one embedding for the entire thing. We started with Word2Vec, and eventually we did Glove. Glove is much faster to train.
Yeah, Glove, okay.
Yeah.
Right, very good. I have some questions here. For instance, thank you, Valeria, for being with us today. She is asking, does your symbolic system use modal concepts to think about in the behavior at the end of times or in some paths?
So right now, our analysis does not involve like time queries. Okay, it's more like state queries, like the ones I showed in the picture. But that's a good point, something that we are thinking about considering for the future, to put time. And especially it becomes important if you try, and it becomes harder if you try to put time together with machine learning and formal together, how we can answer relations among those.
Yeah. So Priscilla, also thank you for your presence. Priscilla is asking, how do you handle negation? Also, how do you go from continuous to discrete?
So the firewall logs are by construction discrete, right? So they're not continuous. And in the same thing for chip design, that we're basically representing the state of the system by just looking at the input and output relation. So I answered that. What was the other question? Sorry.
How do you handle negation?
So negation for us right now is handled very simple. If you specify in the query that you want a query that has negation in the clauses, we switch automatically to the formal engine, because for the formal engine, it's basically reachable state manipulation of the system. And then we just want a state that does not contain certain attributes. For formal, that's a natural way to do it.
Right, right. Antonio is asking, more questions coming. Antonio is asking, I understand that there is a technical man in the loop, as I said, to create the Keras hypothesis from the system output. Do you think about removing this element in the system to alert lay users in a home scenario, or the focus is only enterprises and technical users?
We always, so if you look at what I said, we usually work in several areas. One of the areas that we work is basically probabilistic causal analysis. And we want to be able to actually do causal analysis together with formal and machine learning. Okay, but this is kind of, I don't have a solution right now. And remember, like when you're doing applied research in an entity, we need to roll out the amount of stuff that you're going to be doing so that customers can see advances that you're doing before they see like the end goal that may come like maybe in 2-3 years.
Right. Marco Zendler is asking, and this is something interesting as well. Right now, you are analyzing the past. Basically, we are talking about logs, and it's like a forensics problem. Something happened, and you want to identify it, right? So he's asking something like, could you think of, based on the history that you have, modeling the system to do some kind of prediction of something still didn't happen, but based on what you're finding, it might happen soon?
Yes. Okay. We are looking into that. That's why we basically work on time series together with neural-symbolic, together with causality. The time series parts come that we want to do anomaly detection, time series forecast, and things like that. But on the log, it's kind of hard to detect because logs by itself, it's based like a very nonlinear problem. Okay, because it's a very big state representation. And because of logs, they have, it's like nonlinear, it's like a discrete combinatorics. Then it's harder to do predictions, right?
Yep.
On the logs.
Very good. My colleague, also from Recod.ai, Professor Eduardo Valle, wants to ask orally. So Eduardo, please go ahead.
Thank you, Anderson, and thank you very much, Claudionor. Claudionor was my professor of computer.
Yes, I remember you.
And it's always a pleasure to hear you. So my question is that the mathematical sophistication of all those techniques is very clear. It's very evident. And as a professor, as a teacher, I feel that mathematical background for our students and even for ourselves is kind of a weak point for Brazilian students and Brazilian researchers. I think we have very strong points, but I think that mathematical background is one of our weak points. So in your experience, in your professional experience, how can we start to tackle this weak point, and what are the most profitable parts to start attacking this weakness and to conquer this weakness?
Yeah, so usually the way that I position this is in a slight different way. I started talking to a professor from one of the universities, one of my ex-students, Alex from UFJF. Okay, and we decided that at some point, let's start discussing maybe the possibility so that in the future we do something. And I told him, but if you're going to be talking, I need you to bring someone from the statistics department and someone from the math department. I cannot be talking only to computer science people because I need people to think outside of the box. And the way that I have been doing, even in my team right now, I have people with PhD in statistics and I have people with like the PhD in math in my group at Palo Alto Networks. That's usually how I do to overcome the difference in formation. And that's not a bad thing. That's being able to explore diversity is actually, as I mentioned, going back to my slide about how to build organizations to succeed in applied research. Actually, it's a good thing to be able to hire someone with like, to have a postdoc in statistics that knows nothing about computer science, to hire someone that has background in math that is going to be able to put everyone together to sit and to discuss and to fight. Okay.
Very good. And I totally agree with you. Starting some years ago, I decided to have in my team the most diversity possible. So right now, as I was telling you, I have people with background in statistics, astrophysics. I have 2 people with PhD in astrophysics in my team right now. And also from different places in the world. So this is the best that we can do, bring these people together and work together. So thank you for sharing.
You're never going to, because you're never going to be able to get someone who knows math, statistics.
Exactly.
And to tell you the truth, I know a little bit of statistics and I keep telling people, I know statistics to the level that I'm going to create confusion in someone's mind. The person will say, tell me, I don't know, I know what you're saying is wrong. I cannot tell you why it's wrong. That's my level of statistics. That's why I have 2 people in my team with PhD in statistics, because I tell them, you have to tell me that I'm wrong. And you have to explain me why I'm wrong. Okay?
Exactly. So I have a very good and difficult question for you coming from Priscilla. In your opinion, what is the final frontier for AI or the next one?
Oh God, this is a hard one. So let me give you first a disclaimer here, because I'm basically operating on a level at the industry, and the company is not like the size of Google. So the company needs short to medium term goals. Okay. The way that I see is that from the, so I have to be very narrow focused, and not like the Luis presentation a few weeks ago that he was talking about, let's look like 30 years, 20 years down the road. The way that I'm basically trying to concentrate my efforts in terms of why is becoming harder and harder, okay? And I'm going to give an example in terms of CERN and in terms of firewalls. The attacks are being more and more challenging to detect. And you can think of a way, like suppose that you're talking about a denial of service attack. I'm going to give you some examples that have nothing to do with like long-term AI, but normal day-to-day life. A denial of service attack is easy to catch because at some point there is no traffic in the network, and then at some point the traffic bumps. So because the traffic is bumping, you can catch that something is wrong and you can start stopping it, okay? What we're going to see in the near future is that those types of attacks are going to become more and more elaborate, in which instead of doing like denial of service attack that bumps, that they're going to slowly going up. You know the term cooking the frog, right? If you're cooking a frog and if you throw a frog into like a hot pan, the frog is going to jump.
Yeah.
If you basically increase the temperature very slowly, the frog is not going to catch. The frog is not going to realize that it has been cooked. So what you're going to see in terms of firewall, just to give you the idea of the challenge, we need to start thinking about how to detect problems in your network when those problems are not going to be obvious to detect, but there are going to be very tiny deviations. And in that sense, I keep telling my friends at CERN that I want to know how they detect particles, because the way that they detect like new particles is not by looking at like very fancy behavior, but they try to analyze the noise behavior. They try to analyze how the noise changes, and by trying to estimate the distribution of the noise, the probabilistic distribution of the noise, they figure out that something wrong is going on. So you can think in terms of like just firewall, that we need to start looking into new advances that is going to look in, even if you're talking about predictions on anomaly detection, that are going to be looking into something that is not there yet, that has not been invented, or if it has been invented, it has been invented in a very specific areas, okay? So in terms of AI for the future, yes, I have a self-driving car, but I still drive, I keep my wheels on the car. I don't trust the car completely, okay?
I know the guys that do the algorithms behind that, so I do not trust it yet. So Eduardo has another question here. In that same spirit, that there is very provocative 2021 preprint by Coelho and Benjo saying that the next or final frontier for AI is merging symbolic reasoning with current statistical learning. Could formal methods be something to that table?
Yes, right. So that's a very good point. And that's why I mentioned Luis' presentation 2 weeks ago. I recommend everyone attending, watching that presentation that Anderson recorded. But the idea is that, yes, I truly believe that combinatorics and machine learning, they have very different aspects. And when I'm putting like formal into combinatorics to some degree. And there is a blog by Google that appeared like 2 weeks ago or 1 week ago, where they're basically talking about what if you could merge the normal algorithms that we saw, some combinatorics with some machine learning, okay? And people are starting to look into that to see how it can be used to solve problems in a different way. It's not how to solve problems, but how to solve things in a different way. Okay, and graph neural networks is probably like one of the areas that is basically popping up very strongly everywhere that you go.
Exactly. And as you showed here, you are tackling one very important area, which is I don't have labels. So unsupervised learning is definitely the next frontier, because it is what it is. So I have the data, I don't know what I'm looking for, so what can I do? So I think that this is really a challenge for the field. I have here now Diego Melo. If it is the person that I'm thinking, we were colleagues at the Federal University of Lavras. Diego, please confirm. He's thanking you a lot, Claudionor, for the talk. And it's nice to see Brazilian entrepreneurs creating technology and business from knowledge. He would like to know what you suggest for students to know or study ad hoc during the university to integrate business in their formation and maybe turns into an entrepreneur in the future. And yeah, he confirmed he is my colleague from Federal University of Lavras. Thank you for being here, Diego.
So let me tell you this. One of the best things that I could have done in my career at some point was to do an MBA, okay? Not that and the only regret that I have is that when I was doing my PhD at Stanford, I could have done that MBA together with the class. But at the time I basically said, I just want to be a researcher. And it turns out that learning finance skills, learning like strategy skills and things like that is good. And it's good for several, and marketing too. Remember what I basically told you in the presentation. Let's see, there's a slide here. You have to understand this part here, okay? If you're going to be doing something, nothing works in isolation right now. The time has ended when by doing just something in isolation and publish, the world would recognize you. Right now, more and more, it's important that your network publishes, your contact network and support network, they publish together, okay? And you're going to see several times. I was not the first one who created and who published things on quantization and machine learning, but the fact that we worked on a strong network with the CERN and with Google enabled us to have a very strong piece of work that was recognized. And I don't have any problem in saying that it's thanks to my colleagues in CERN and thanks to my colleagues in Google that we have that piece of work being widely recognized. Okay, so that's why I think if you could follow my advice in something like do entrepreneurship classes when you're still young, be not afraid to take risks. When you get older, then you are going to be more risk averse. But join a startup, try to do certain things. I used to teach entrepreneurship in the UFMG. Eduardo, did you take entrepreneurship from me?
I think if you want to ask Eduardo, you can go ahead.
Yes, I cannot unmute myself. But the moderator has to unmute the participants. I took entrepreneurship, Claudionor, but it wasn't with you.
Okay. And I used to, yeah, and it's very interesting because the class that I used to teach is very different than the class Cristiano used to teach.
Yes,
Professor Cristiano.
Yes.
My class was based on finance, strategy, and product design. It has nothing to do. I said when Yahoo was sold, and I did my PhD with you guys from Yahoo Group. Yahoo was sold on a PowerPoint, and they didn't even have like an Excel spreadsheet. Okay? So learn how to create spreadsheets for finance applications. Learn how to create like strategies for a startup. This is the MBA or like a business school people. They will teach you how to do that, and marketing too. It's going to help you carry that over even if you're academic. That's going to help you a lot.
O Fernando Jefferson está dizendo aqui que ele discorda um pouquinho de que só gente jovem pode inovar. Eu concordo com você, Fernando. Eu já te falei isso, que é o inovador que está começando. Ele é um jovem. Ele não inovou ainda, então pode ter qualquer idade.
Yes, I did not say that it was only young people that could do that. I said risk averse. Okay.
Yes.
Because what I said in terms of risk averse is very natural. After you get older, you have more financial responsibilities towards kids and towards the stuff, right? And because of that, it's natural that you're not going to go in a kamikaze mission.
Mm-hmm, mm-hmm.
Okay.
Another point that you mentioned, and I remembered, the University of Colorado at Colorado Springs, while I was doing my PhD there, they created the Bachelors of Innovation, which is one of the first of the US of its kind. It's a mixture of computer science, finance, and entrepreneurship. So it's a very nice way that they created this. And doing some advertising here for those interested, we are creating at the Institute of Computing some disciplines of entrepreneurship that will be offered online. And the first one that we're going to give, it's a total course, and it's taught by the founder of Movily, one of the founders of Movily, which is nowadays one unicorn worth more than $10 billion. He will kindly offer this course for the Institute, and anybody that's interested will be able to attend. And complementing Claudionor, here's a book that I love, and I recommend if you want to think boldly, as he is suggesting. So it's a short book by Peter Diamandis, and there is the English version and the Portuguese version. It's called Bold Exponential Opportunities. It's basically what Claudionor mentioned. Find the niche that you can contribute to and think without fear of committing errors, which is something that Brazilians have as a problem. Many Brazilians have the problem of being afraid of committing errors. And to be an entrepreneur or innovator, you cannot be afraid of everything, right, Claudionor?
And to tell the truth, I was the VP of a company that went down. NVXL, for example, we test the market. We were building machine learning accelerators for the cloud. We got some stuff that I did. We were able to get like $15 million from Alibaba as an investment. And then when we had the first version of the product ready, went to Google, Facebook, Microsoft, and they said, "Are you going to use that?" And the guys looked at us and told us, "Look, when I say that I'm going to build my own team to do machine learning acceleration, the stock price of Google, Facebook, or Microsoft increase. What you're giving me is a solution to reduce cost, but the value is much more valuable than the cost."
Yeah.
Okay, so at that time, we decided that it would not be good to continue with our product, and then the company ended up like closing. And I learned something, and I use what I learned in my next endeavor. Okay.
Exactly. The next thing that you do will be better than the last. So it's
Yes.
always learning. I always like to finish these awesome talks with a question about experience. So if you were to give some advice to a student starting computer science or wondering if he or she wants to enter artificial intelligence nowadays and is starting, so what would be your advice or advices?
Study statistics.
All right, everything is statistics.
I think that more and more that the amount of data is so large that more and more you're going to depend more on statistical methods. Even if you decide to go eventually to something that is combinatorics or something like that, having a statistical background, it always pays off.
I also tell that to my students. It's basically statistics and linear algebra. The rest you can get.
But the statistics is harder to grasp.
Yes.
Sometimes
yes,
you reach the conclusions that goes against what you initially think on if you basically think about statistics. And always try to think outside the box. Okay.
Definitely. So Claudionor, thank you very much for the awesome discussion. I hope to have an opportunity again to have you here with us. Marcos, would you like to say some words? Let me see if he's having the problems of unmuting.
Yeah, now I can. Okay, so Claudionor, thank you very much. I think it was a very interesting talk, and where we learned a lot from your experience as an innovator, as an entrepreneur, and a researcher. So it's very interesting, in fact, because here as a professor at the university, we only see part of the world in some sense, only the research part and a bit of the innovation, but not the market part. So it was very interesting. So thank you very much for your talk. Very good to know you. And I also hope that we can meet more times. So thank you very much.
Thanks a lot, Marcos, and thanks everybody coming from PUC-Rio. It's very important to have you as partners in the Conexão Rio-Campinas. We hope to have many other events like this. Claudionor, once again, thank you very much. You gave people here lots of ideas, not only in terms of technical expertise, but also in terms of innovation and how to be bold. Thank you.
Thank you.
Thank you. Bye-bye.
Bye-bye.